This will be the first of a series of videos where I demonstrate how to mutate and simulate a protein. In this case, we're looking at a beta-hairpin peptide. This is the tryptophan zipper 1LE0 from the protein data bank. And you can see that it forms a beta-hairpin with 4 tryptophan responsible for the formation of that structure. And this structure, when downloaded from the protein data bank, consists of 20 frames. It was studied using NMR, and so there are 20 structures that can be seen. If you press the play button, it will fluctuate through these 20 structures. And so what we want to first do is just save one of the frames for further simulation. Another note about this is it has an amide at the end terminus, and we're going to leave that off. It might help with solvation, but for this demonstration, we're going to ignore that. So what I'll do is I will set a variable called frame 0, and in it I will store the protein part of the structure, ignoring that amide at the end terminus. And I'm only going to store frame 0 in this selection. I currently only have one structure open, and so its ID is 0. It's also the topmost molecule. I'm just, for simplicity, going to select my topmost molecule. In this case, it's the only molecule. And I will select the protein part of the structure and only frame 0. Once I have that selection, I can then output it to a new PDB file. I will call it 1LE0 frame 0. And then what I'll do is I'll open that structure to check that it saved properly. And I will hide the previous PDB file that has the 20 frames, and we can see the new one only has 1 frame rather than 220 atoms. It has 217 because we removed that NH2. And just to check that the structure looks okay, I will create a representation that shows me that it still looks like the beta-hairpin. And I'll check that the tryptophan are still there in the same places. And we can see that the structure looks correct. The next thing I want to do is save a structure file. And so I will use the automatic PSF builder, and it will automatically load my topmost structure. It guesses topology files. The basic ones usually work, so I'll load everything. I'm going to guess, and you can see that it created a new structure. And I'm just going to jump to the end and say I'm feeling lucky. I'll just check in the console. There are some poor guesses, but it looks like it created the structure. And I'm just going to delete everything and reload to make sure everything loads properly. Now when we have a PSF structure, so I'm going to load a new molecule, I'm going to browse, and it will be called auto PSF, and I'm going to first load the PSF file, and then on that I'm going to load the PDB file. And again, I'm just going to check that everything looks okay. OK. And again, that structure looks the same as before. So we've created a PSF and a PDB file that we can simulate. In the next series of videos, I'll show how to solvate and mutate this, and then finally how to simulate it and analyze the trajectories of the simulation to determine if mutating one of these tryptophan has an effect on the structure.